Hello, and welcome to Module 8.4, Rational Exponents. Our objective for today is that I can rewrite expressions involving nth roots and rational exponents, and that I can rewrite expressions involving powers of nth roots and rational exponents. So let's define first what a rational exponent is. These are going to be exponents that are expressed as a fraction. So any fractional exponents are our rational exponents. And we have a rule here that b to the 1 over n power, b to a fraction, some number, any real number, to any positive integer is going to give us the nth root of b. So for example, if it was, x to the 1/2 power, that is the square root of x. Okay, y to the 1/3 power is the third root of y. Okay, so these are just two examples here. Now let's talk about what these two parts are. First of all, we have the index. The index is the degree of the root, and it's the denominator of the fraction, right? And that's what we see right there. We put it in the little nook of the radical symbol, okay, or radical sign. The second definition here is the radicand, and that is what is under the radical sign, and that's your base. Okay, so that's your radicand. It's your base, and that is what's being raised to that rational exponent, that fractional exponent. All right, let's look at example one. In example one, we're told to write each expression in radical or exponential form. So we're just changing from one form to the other. So if I zoom in on it and I look at 34 to the 1/2 power, 34 is my base, okay? So 34 is the base, and then 1/2 is my root, my radical, or my degree of the root. So we have our radical symbol. The base is 34, and it's a square root because it's 1/2, so we just don't write the number in when it's a square root. So that's why many of you will look at this and say, well, that's the square root symbol. It's technically a radical sign or a radical symbol. It's just that we don't write the 2 in for the square root. So letter B, we have x to the 5th power. So we're going to start off with our radical symbol. We start off with our radical symbol, and we need to put our base inside of it. So our base is x, and it's being raised to the 5th power, so we put a 5 in the nook of the radical symbol. So that tells us we are taking the 5th root of x. Okay. Letter C, we have it in radical form. We need to write this as a fraction. So we start off with our base is y, and our exponent is, we're to the 3rd root, so it's 1/3. Okay. Letter D. Well, letter D, we have two things that are inside the radical. So those are the base. So we keep them together and we put them in parentheses. And this is to the 1/2 power because it is the square root. All right, there are 4 you-try problems that I would like you to do on your own. All right, letter E. We're going to start off with, we have our radical symbol. It is the 1/3 power, so that's the 3rd root of 8. Letter F, we have something that's in parentheses. That is our base. So we have 4y. Actually, we don't need the parentheses because we're putting this inside of a radical. So we have our radical. We put 4y on the inside, and it is to the 1/3 power, so it's the 3rd root of 4y. Letter G, we have x, the 4th root of x. So that's going to be x to the 1/4 power. Okay. And letter H. We have the square root of 64. So we would write that as 64 to the 1/2 power. Now let's take a look at example 2. Evaluate nth roots. So the way we evaluate these roots, we are looking for groups of that amount of factors. So how do we approach this? What we do is we're going to do factor trees, and you may remember these from previous grades, but we're going to break out our number, our value that we are taking the root of into factor trees. So 8 is going to be 2 times 4. And then 4 is 2 times 2. So we could rewrite this as the cubed root of 2 times 2 times 2. Okay. Now, the degree of your radical, the degree of the radical there, tells you how many of something you need to have for it to be taken out of the radical. So we have 3 groups of 2 here, so we're going to bring out a 2, and that's my final answer. Because what you're looking at, the cube root is the inverse of cubing something, right? So 2 times 2 times 2 is 8. 2 cubed is 8. The cube root of 2 is 2. So you're trying to go back and forth, right? So we're going to break down our factors, and we're going to look at our index, and that's going to tell us how many of that factor we need in order to bring it out. So letter B, we have the 5th root of 243. So my first level, 243, I'm going to just take a stab in the dark and say we can divide that by 3 because 24 and 3 both get divided by 3. So I'm going to take a stab in the dark, and that's in fact one of the factors. So it's 3 and 81. Well, 81 I know is made up of 9 and 9. And 9 and 9 I know are 3 and 3. 3 times 3. So we are looking for the 5th root. So I'm looking for a group of 5 of a value. And so we have 5 threes there. And so we are going to bring those 5 threes out. And the 5th root of 243 is 5. Right? Because if we were to take that 5 to the 5th power, sorry, I did that wrong. Our root is 3, and if we did 3 to the 5th power, 3 times 3 times 3 times 3 times 3, we would get 243. Letter C, we have 2401, and we are trying to find the 4th root. So 2401, let's break it apart. So 2401, let's start with a 7. And really, at the beginning here, you're going to be just guessing and checking as you try to find what these factors are. And then once you identify one of them, you ideally want to try to keep going down that down that trail to see what you have. So 243, let's see if we divide that by 7 again, we're going to get 49 as my value, which we then divide by 7, and it's 7 times 7. So 7 times 7 times 7 times 7. We said we were looking for a group of 4, and I did in fact find a group of 4 of one term. And so the 4th root of 2401 is 7. All right, I want you guys to try letters D, E, and F on your own. You're going to break apart their factors and look for look for the value that's being repeated. All right, letter D. We have the cube root of 125. Well, anything that ends in 5 we know is divisible by 5. And so it's 5 times 25. And 25 is 5 times 5. So if I look at my values, I have a group of 3 5s, so I can bring it out. And so the cube root of 125 is 5. 5 times 5 is 25, times 5 is 125. Letter E, we have the fourth root of 81. Well, 81 we know is 9 times 9, and 9 is 3 times 3. Do we have a group of 4? Yes, we do, so we bring it out, and our fourth root of 81 is 3. Letter F, 625, and again we're looking for that fourth root. So 625, we've got 5 and 125, and then we just broke this down a little bit ago. And so now, as we see it, we've got 1, 2, 3, 4 5s, and so we have a 5. All right, we're going to go on to the next page, and we're going to evaluate exponential expressions with radical exponents. So what we did was we rewrote this in radical form. So we start with the third root of 27, and now we need to go through and break it into its factors. So 27 is 3 times 9, and 9 is 3 times 3. So do we have a group of 3? We do. The 27 to the 1/3 power is 3. Now, letter B, we are applying this exponent, and if you remember our exponent rules, we applied that 1/4 to both the top and the bottom. So we have the fourth root of 81 over the fourth root of 256. Now, we know we've worked with 81 before. We know that that is going to be the fourth root of 3 times 3 times 3 times 3. And 256 we've maybe not seen quite as often, but we can work with that. And we know, we're going to break it up by 4s. So it's going to be 4 times 4 times 4 times 4. And when you go ahead and you take those roots, you get 3 over 4. Because you'll have a group of 4 3s and a group of 4 4s. Letter C, another one where we are applying that exponent to both terms. So we need the square root of 64, the square root of 100. Those are numbers that you should be able to do in your head. The square root of 64 is 8. The square root of 100 is 10. And lastly, a fraction is always needing to be reduced in our class. So 8 over 10 reduces to 4 over 5. Now, could you have simplified this beforehand? Sure, you could have. You would have gotten 16 over 25 if you divide both of them by 4. 16 over 25. Square root of 16 is 4. Square root of 25 is 5. 4 over 5. Doesn't change things. I went with it as is just because I recognize it as a perfect square. All right, I want you guys to try D, E, and F on your own. Go. Letter D, we've got the fourth root of 16. So we rewrite it as a radical. 16 is our radicand. So now, break it apart. 16 is 4 times 4. But we're not looking for the square root, we're looking for the fourth root. So we keep looking, and 4 breaks down to 2 and 2, and so does that 4. And so now, do we have a group of 4? Yes, we do. The cube root of 16, or not the cube root, the fourth root of 16 is 2. 2 times 2 times 2 times 2. Letter E, we're looking for the third root of 125 over 64. So we have the third root of 125 over the third root of 64. Third root of 125, we've worked with this one before. We know that that's going to be a 5. 64, what does that break into? Well, we've got 4 times 16 as a possibility. Or actually, let's do it another way. 64 is 8 times 8. Okay, this is going to be a longer way of doing it. 8 and 8, that breaks into 2 and 4. And 4 breaks into 2 and 2. So I initially started saying break it up by 4s, but that was me just knowing what these factors look like. Instead, you could always take it to your prime factors, and then you're looking for what we need is groups of 3. So how many groups of 3 do we have in our prime factors? We have 1, 2, 3 2's there, so that's one group. 1, 2, 3 2's there, that's another group. So we can bring out 2 groups of 2. Right? And if we have 2 groups of 2, what's 2 times 2? 2 times 2 is 4. So you have 5 over 4 as your final answer. So if you don't know what your prime factor is immediately, you can always go, or if you don't know what the root is immediately, you can always take your prime factors. And once you get to prime, now you just look at how many groups do you have, or how many of the target do you have, and then bring those to the outside. And then you'll just have to multiply at the end. Right, so you could have done 4 times 16, and 16 is 4 times 4, and now you've got 3 4s that you could bring out. But instead, we did it twice. We did 3 groups of, or 3 2's and 3 2's, so we brought 2 times 2. All right, letter F, we have 81 over 256. We've just worked with a couple of these numbers, so we rewrite it. It is the square root of 81. Sorry, not the square root, the fourth root of 81 over 256. And when we break that down, you got 3 over 4. And I'm not showing the work because we just worked with each of those numbers individually on a previous question. And that's the identical question. Never did change that. Oh well. All right, example 4, we are going to evaluate expressions of powers of nth roots. So our description of this, for any real number b and any integers m and n that are both greater than 1, the b to the mn is equivalent to the nth root of b to the mth power, or the nth root of b to the m. So either you can put the exponent on the inside or the outside of the parentheses. It doesn't really matter. Both are equivalent. And this is except when b is less than 0 and n is even. Because if n's an even number, you'll be able to simplify. All right. So, well, actually, no. When n is an even number, it's because if b is less than 0, then you're taking an even root. So if you have a negative value inside of your radical and you're taking a square root or a fourth root, you cannot get that. You will get imaginary numbers if you do that because you're taking the square root or fourth root of a negative, and a negative times a negative, or negative times negative times negative times negative, will always be positive. And so there's no way to get a negative. Now, if it's an odd root, if it's the third root, right, if you had negative 3 times negative 3 times negative 3, you are still going to get a negative value. So a negative inside your radical is okay if you're taking an odd number root. So we have a couple examples there, and we see that the 216 to the 4/3 would be the third root of 216 to the 4th, or 6 to the 4th, or 1296. And then you have another way of writing it where you've got 32 squared. 32 squared becomes 1024, which is 4 times 4 times 4 times 4. And when you take the fifth root of that, it's just 4. So let's do a little work with this. First of all, let's look at letter A. Letter A, we've got 4 to the 15 over third power. Well, 15 over 3, can I reduce that fraction? I can. I want to reduce fractions if I can. So when I do that, I get 4 to the fifth power And when I do 4 to the 5th power, what do I get? I get 1024. Now, we have 1 over 16, 1/16 to the 1/4 power. So we're looking for the 4th root of 1 over 16. Well, I know 16 is 4 and 4, and 4 is 2 and 2 in terms of factors. So I'm looking for the 4th root. There's a group of 4 2's, so I bring 1 out. 1 is just going to be 1, and you have 1/2. Okay, so now we've got 49 to the 3/2 power. So we can rewrite this. You can write it in one of two ways. It's the square root of 49, and we can put that 3 on the outside, right? Because 49 is a perfect square that we can take a perfect square of. We can work with that, right? Because that's 7 and 7, and it's a square root. So we have 7 to the 3rd power, which is going to be 343. Now, could we do the square root of 49 cubed and we do the 49 cubed on the inside? We could. 49 cubed is going to be 49 times 49 squared. 49 is 7 times 7. 49 squared is 49 and 49. And that's 7 times 7 times 7 times 7. And we're looking for the square root. So how many groups of 2 do we have? We have one group of 2, two group of 2's, or two 7's, and then we have another group of 2 7's. So that would be 7 times 7 times 7, which is the same as 7 to the 3rd power. So that's kind of the rationale of how this can work both ways. You can use it as the exponent on the outside and you're applying it afterwards, or you can use it with the exponent on the inside. The caution I will say on having the exponent on the inside is you will get large numbers. You will get larger numbers than you may otherwise be comfortable working with, which is why I didn't actually do 49 to the 3rd power, because when I would look at that, I wouldn't necessarily know immediately where to go with on starting that. So I just kind of broke it apart using powers instead, and simplified that way. All right, so we've got 64 over 100 to the 3/2 power. The first thing I want to do when I see this one is 64 over 100. That can be simplified. I can divide that by 4, and I'm going to get 16 over 25. Okay, and when I do that, that whole thing is still being raised to the 3/2 power. Okay, so we've got 16 over 25 to the 3/2. So I'm going to write that as some roots. So let's do the square root of 16 to the 3rd over the square root of 25 to the 3rd. We're still keeping this applied the same way. So square root of 16 is 4 to the 3rd power. Square root of 25 is 5 to the 3rd power. And what's that going to equal? 4 cubed is 64. 5 cubed is 125. So since I was dealing with a square root, right, it's to the 3/2 power, so that's a square root. And I already knew that I had 2 perfect squares on the inside. I just simplified the square root first and then applied the exponent to it. All right, we're going to turn to the next page, and you are going to do the U-try problem on these. Go ahead and get started on those 4, and then check your work against mine. All right. We're looking for 729 to the 5/6 root. So we rewrite it as the 6th root of 729, and we need to start breaking that into factors. And it's going to take some guessing and checking. I suggest use your calculator on it. 729, you can divide that by 9, and it's 9 and 81. 9 you break up into 3 and 3. 81 breaks up into 9 and 9, which goes to 3 and 3 and 3 and 3. Right, and we still have that fifth on the outside. So do I have 6 of one value? I do. I have 6 threes that I can bring to the outside, and I have 3 to the fifth power. And 3 times 3 times 3 times 3 times 3 is going to give me 243. Now, could you raise 729 to the fifth power? Yeah, you could. I don't know why you would want to. I would simplify it and then apply the exponent. All right, letter F, we have 1 over 8 to the 5/3 power. So we rewrite that. We're taking the third root of 8 and we are raising it to the fifth power. So cube root of 8, of not 8, 1/8, because it's 1 over, so it's 1/8. So cube root of 8, well, that's 2 times 4, which is 2 times 2. So you have 1 over 2 to the fifth power, 1/2 to the fifth power. And when you multiply 2 times 2 times 2 times 2 times 2, you get 1 over 32. '81 we're taking to the, this didn't get changed, it was supposed to be 3/2 power. So 81 to the 3/2 power. We've got the square root of 81, and we have the square root of 81, and we're cubing it. Now, 81 is a perfect square already. 9 times 9, there's our 2 that we bring out. So it's 9 to the third power, and 9 to the third power is 729. And our last question, letter H, we have 243 to the 3/5 power. So you have the fifth root of 243, and that's being cubed. So 243, I can break that up into, let's see, it's going to be 3, and that's times 81. 81 breaks up into 9 and 9. 3, 3, 3, 3. So we've got 5 threes that we're going to bring out, and that's still to the third power. So 3 times 3 times 3 is 27. All right, so now we're going to apply rational exponents. You can estimate the metabolic rate of living organisms based on body mass using Kleiber's law. The formula R equals 73.3 times the fourth root of m cubed relates the metabolic rate R measured in calories per day to body mass m measured in kilograms. What is the metabolic rate of a dog with a body mass of 18 kilograms? All right, so we're starting this. We've got 73, so we want to know R equals 73.3 times the fourth root of 18 cubed. All right. So when you do that, this is one where you're going to end up with a decimal because you are not going to be able to pull this cleanly because let's just do, you've got 18. Its factors are 2 and 9, which is 3 and 3. And we're doing that 3 times, right? So that would just be 1. So you have triple that. You're not going to be able to pull out clean factors. You'll have a total of 6 threes and 3 twos. You won't be able to get everything outside the radical. So for this one, you're just going to use your calculator and we are going to do the math on this. All right, now we'll walk you through in class on your specific calculators how to use them. But what you could do is write, since you do know how to do fractions and you do know how to do exponents, you can do 73.3 times 18 to the 3/4 power. Okay, make sure you put the 3/4 in parentheses so that the division is actually being done as the exponent and not as a division after the fact. So now when you do that math, you do type that in, you are going to get that R is going to equal 640.56 calories per day. Okay, so and go ahead and round that to the hundredths place, that's fine. All right, letter B. The frequency of a note measured in hertz or vibrations per second played on a perfectly tuned violin is given by the formula F equals 440 times 2 to the n over 12 power, where n is the number of notes above the note A4. What is the frequency of A6, which is 24 notes above A4? Well, let's substitute what we know. We have F is equal to 440 times 2 to the n. N is how many notes we are above A4. And so it's 24 notes above A4 over 12. And we can simplify that. F is equal to 440 times 2. 24 over 12 reduces to the second power. So you have F equals 440 times 4. And when you do that, the frequency, 440 times 4, is 1760, and we are measuring that in hertz. Hz is the abbreviation for hertz, as you know from science class. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.